Welcome back, everybody. Hope you all had a good weekend. Today, what we're going to be doing is we're going to be talking about lesson 14. And so that is in your digital copy of the book. So feel free to follow along in that. But you can also just kind of follow along with watching what we're doing here. What we're looking at today is whether we can determine whether two triangles are identical, not identical, or if we have enough information to determine whether the triangles are identical. And what we're going to use to help us determine this is going to be the different triangle rules that we talked about last week. And so I wanted to start off by talking about those. The rules that we're really talking about are angle, side, angle. So if we see an angle followed by a side followed by an angle that are all labeled the same on both triangles, they'll be congruent. That's also true for angle, angle, side. We'll have side, angle, side, and then side, side, side. Now there is a fifth one that we don't talk about too much, especially in 7th grade, but we can use, and we may actually use today, and that's hypotenuse leg. But this only works for 90-degree or right triangles. So that's one thing that we'll want to keep in mind. There will be one example where it is talking about that. So with that being said, we're going to open up with example 1 here. And if we look at these two triangles, we have triangle ZWY and XYW. Are these two triangles congruent? So these two triangles share a side, WY, down the middle. And since they share that side, it means that that side is the same for both triangles as well. Therefore, they have 3 of congruent corresponding sides. Therefore, those two triangles are congruent based on side, side, side. So we're looking for any one of those combinations of angles and sides to determine if two triangles are going to be congruent to one another or not. And congruent and identical essentially mean the same thing there. Look at these two triangles here. We have triangle QRT and triangle RST. Do they share anything? Hopefully you're saying that they share this side right here, TR. And so now we have an angle followed by a side followed by a side. Now, I'm not going to spell that out, but anytime that you see angle, then side, you know that that's not going to be, or at least not enough information to show whether or not these are congruent triangles or not. So with this one, we can say they are not identical triangles, and the reason why is because we don't have enough information to say whether or not they're congruent triangles. How about this one? So what I'm seeing here is that they do share this side, HF. So we have those two triangles, and we see that this angle is congruent to this angle right here. What we should also see is that if this line goes straight down, and we know that EG is also a line, if it makes a 90-degree angle here, it also makes a 90-degree angle over here. Therefore, we have an angle, another angle, and then a shared side that they both have. Now, if we look at our rules, angle, then side, shows us that this is enough information to show that these two triangles are congruent to one another. Now, one last thing that I want to talk about is writing what the congruence is going to be. So we have triangle EFH. I'm going to write that, triangle EFH. And we want to show that that's congruent to the triangle with the other letters as well. Now, E corresponds with what angle on the other side? So E corresponds with G, and we said EFH. So if we know that E corresponds with G, we know that that's going to be our first letter. Then we just have to decide whether F or H is going to come next. Well, the nice thing is that F should be F in both of the triangles. Same with H. And so when we're writing our triangle correspondence, the only thing that's going to be different is the first letter in both of those. For some reason, this is not zooming very nice today. There we go. So with that being said, We can also look at something along these lines, and this is where it's going to be important that you understand how angle relationships work, because that's something that we have talked about in the past, and that's something that we can use here to determine whether these two triangles are identical. I want you to look specifically at angle AOC, so this angle right here, and angle DOB, or this angle right here. What type of angles or angle relationship do those two angles have? Those two angles are vertical. And what we know about vertical angles is that they are congruent. So they have the same measure. Therefore, we have a side, then an angle, and a side. And on the other triangle, we have a side, then an angle, then a side. Is side, angle, side one of our triangle congruence theorems that we can actually use? Yeah, it's one of our 4 right here. And so just by seeing that we have a side, angle, and side that are all congruent on both triangles, that's enough information to show that these two triangles are congruent to one another. So now I want you to take a look at this one. What do you think? Are these two triangles congruent to one another or not? Now, once again, we do have 2 vertical angles right here. So what we're going to be looking at is an angle here, a side here, and it just so happens that if we have angle, angle, side, that is one of our rules. We do have enough information to say these 2 triangles are congruent to one another. Now, this one I like a lot. Once again, there are vertical angles, but are these 2 triangles congruent to one another? You'll notice that angle, angle, angle is not one of our rules, and I want to show you why it's not going to be one of our rules. Say you have a triangle that's an equilateral triangle. What does an equilateral triangle mean? So equilateral means that all the sides are equal, and it also means that all of the angles are equal. Now, an equilateral triangle, I want to focus in on the angles and show you why angle, angle, angle does not work. An equilateral triangle, if all of the angles are the same, has 60-degree angles for each one, because the angles on a triangle should total up to 180. Well, we could also draw another equilateral triangle that has 60 degrees, 60 degrees, and 60 degrees. Now the problem here, we know that those three angles are congruent on both of the triangles, but are those triangles the same size? Definitely not. I mean, obviously this one is a lot bigger than this one here. So that's one thing that we'll want to be careful with, and that we're not using angle, angle, angle as one of our rules. So this is the one that I wanted to end on today. And the hypotenuse leg rule is one that you saw in your video last week, and it's actually the rule that we are going to be using here as well. Notice how I said that that only works for 90-degree triangles or right triangles. We can clearly see that these 2 triangles are right triangles. So they do have this angle here. We also know that they share this side. So automatically we see angle, side, side. And we know that angle, side, side is not one of our triangle congruences. But because this is a right angle, it means that this is the hypotenuse of that triangle. The hypotenuse is the longest leg of a triangle, and the reason why we know it's the hypotenuse is because it's opposite the largest angle of the triangle. Now we have the hypotenuse and a leg of the triangle that are the same on both, and if we look back to our rules, hypotenuse leg for a 90-degree triangle is enough information to show that those 2 are congruent. So in this case, those 2 triangles are going to be identical. Now, I just did a few examples just because I wanted to get you guys kind of used to this. What I'd like you guys to do is look for those 4 things, that angle, side, angle, side, angle, side, angle, angle, side, 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 and see if you have enough information to determine whether they are going to be identical or not. What I would recommend trying, if you have some time, is take a look at the problem set. And it's not too long. It looks like a lot, but that's just because of the diagrams there. And even if you don't want to do the whole problem set, maybe try just a few of them. So if you look, it goes on for a few pages, 10 questions altogether. it would be really good for you to get a little bit of practice with this. And we'll talk about it next time that we do have a Google Meet to kind of go over it in a little bit more detail. Thanks for watching today. And as always, if you guys have any questions, please make sure that you are asking me. We're getting close to the end, guys. Next time.